We basically give the machine its life. I'm Christian Gartz. I'm the head of the software department in commissioning and electrical design at Zimmermann. We accompany the machine from its initial commissioning, the very first time the switch is turned on, all the way to acceptance with the customer, and we get to do exactly what the customer requires. The machines are always custom made. It's actually quite rare for us to deliver the exact same machine more than once. So right now we have our first project where we've sold a digital twin along with the machine. In the future, the plan or vision is that we will be able to test a lot of software in advance using the digital twin. That means currently we have relatively long downtimes on the shop floor because we have to test many things on the real machine first, since we are in special machine construction and there are many innovations. If you can test that in the digital twin, then you already save a lot of time on the shop floor, which reduces costs and also shortens delivery times. That's an advantage for us. The advantage for the end customer is that if they have the digital twin, they can already in advance during the production phase of the machine, depending on the status, test their processing programs, conduct training and run trials on the system, which given the setup and size of our machines can be a major benefit. But one should not underestimate that the effort involved in creating a digital twin is, in the end, like commissioning a real machine. So you also have to be careful as a manufacturer not to end up doubling your workload. There is machine safety and there is cybersecurity. Machine safety, in the end, is the safety aspect of a machine. That means I protect people from harm caused by the machine. And cybersecurity is actually the network inside the machine. So all digital participants, let's say, that have an IP address fall under the topic of cybersecurity. You have to try to secure everything in such a way that there are no vulnerabilities if a hacker comes and hacks into one of the participants. For example, we have an IPC installed and as a result, the machine changes its mode of production or simply operates in a different way. That can, of course, lead to something that isn't obvious at first glance, but later on, for example, if it's installed in an airplane, it can have fatal consequences. The Cyber Resilience Act is an EU regulation and simply stipulates what must be done to ensure security in the machine from a networking perspective. We have been intensely engaged with this topic for several months now. That means we attend workshops, we go to presentations, and we've had consultation meetings. We now have to more or less free up our employees so that we can focus even more intensively on this, because due to our machines' delivery times by the end of next year or the beginning of 27, as a result of the machinery regulation coming into effect, and since part of the machinery regulation essentially refers to the Cyber Resilience Act, we need to ensure that our machines are already suitable for this. In the future, however, I believe that AI will become increasingly valued in our field. So we're already on a good path because we started dealing with it early on, and there are also many opportunities that could arise for us as a result. What really motivates me is the technology itself. I'm simply a technology enthusiast, especially when it comes to IT topics, programming, and so on. I've been doing that since I was a kid. Bringing a machine to life here, which later produces an aircraft part, and then when I go on vacation, I'm sitting in a plane that has a part made on my machine. That's just, I can't put it any other way. Awesome and a lot of fun.